Guys, how's it going? This is Derry here recording your 3.1 notes. I am out today, so I want to make sure we still stay on schedule and you guys get some notes for today. So the nice thing about 3.1 is it's taking everything from chapter 2 and just combining it. So there's no really new concepts, but just a new way to find a solution. So we are going to work with a system of linear equations. What that means is you have more than one equation. So we will be dealing with linear systems. So that's our y equals mx plus b. So the solution, remember solution means the answer, to a system of linear equations is the intersection points. Okay, that's your x comma y value. So wherever they cross, that's what your answer is. That answer means that it satisfies both the equations, which is what we are looking for. So, for example, your goal is to always make sure that your equations are in y equals mx plus b form, right, where you can easily see what the slope is and what the y-intercept is. So first step is look through your equation. This one is okay to graph. I'm going to graph it in red. Second one is also okay to graph because it's in y equals mx plus b form. So graphing my red one, my y-intercept is at positive 2. So I'm going to place a point on 2. From there, my slope is 1, right? There's a 1 in front of that x. Whoops. There we go. Okay. So that means I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You could also go down 1 over 1, right? Because down 1 would be negative, to the left 1 would be negative, which makes a positive number. Now, my hint for these is to plot as many points as you possibly can on your graph. And I will explain why in a minute. Okay, doing the second one, my y-intercept is negative 2. My slope is 3. So rise 3, run 1. Up 3, over 1. Up 3, over 1. Down 3 to the left 1. And I can't fit another point. So your intersection point is where they touch, right? Now that green circle, that is your answer. So you want to look at what the coordinate pair is. So on my x-axis, I go over 2, and I have to go up 1, 2, 3, 4. So your answer is 2, 4. Okay, and again, make sure you graph as many points as possible. Okay, so let's try the next one. So again, feel free to grab colored pencils if you want to do one of each. That always helped me. I'm just going to keep the same colors as before. We'll do one red. I'll do another one blue. Notice they are both good to graph because they are both in our form. Y equals mx plus b. So graphing the red one, my y-intercept is 4, my slope is 2. So that means I'm going to rise 2, run 1. Can't go any more up, so I'm going to go down. So down 2 to the left 1. Again, going down means negative, going to the left means negative. So if you notice, it ends up being a positive slope, which is what we want. Now doing my blue line. My slope is 1, so up 1 over 1, up 1 over 1, up 1 over 1, and so on. Down 1 to the left 1, down 1 to the left 1. So you can see my intersection happened right here, which has the coordinate pair of 2, -2, 0. Again, realizing that your x value is your horizontal distance, your y value is that vertical distance. Okay, go ahead and try this one on your own. I would pause the video while I do it and then check your answer at the end. So if you're having trouble, I'm going to still walk you through it. So y-intercept for my red line is going to be -6. From there I go up 1 to the right 1. My slope is 1, so I'm going to keep going until I run out of space. My blue line, this is like saying +0, so my y-intercept is at 0, 0. My slope is -2, which means go down 2, but then to the right 1. So down 2 over 1, down 2 over 1, or up 2 to the left 1. Ordered pair should be to the right 2, down 4. Again, this is your x value, which moves left to right. This is your y value, which moves up and down. Okay, so I need to see that as an answer. Okay, moving on to the next one. So again, notice that they're both nice to graph. So I'm going to go ahead and graph them. Slope's a half, so that means go up 1 over 2, up 1 over 2, up 1 over 2, or down 1 over 2. My blue line, go up 1 over 2, now you might be thinking we graphed it wrong because notice they don't ever touch. However, this is a special type of solution. These are parallel lines. And if you notice, you guys have learned that parallel lines have the same slope. So anytime you're dealing with a parallel line, meaning it has the same slope as another line, you're going to have no solution. And that's because they don't ever touch. Okay, now the ones below, if you notice, they're a little different than what we've worked with. They are not in y equals mx plus b form. So your goal is to get them into y equals mx plus b form. Okay, so going through the steps, first step is move the x to the other side. Second step is get rid of number attached to your y. I know my writing is hard to read right now. I'm using a different program than usual, so just bear with me. All right, so let's try this out. Number 1, I'm going to rewrite my equation. 2x plus y equals 5. So first step, move that positive 2x to the other side by subtracting it. Y equals negative 2x plus 5. Okay, now I like to put my negative 2x in front. You could have also had 5 minus 2x, but we're so used to seeing this value first and then our y-intercept. I'm going to go ahead and actually graph that one. Okay, my second equation. Again, you should not erase this stuff on yours. Hopefully you wrote it smaller than I did. Negative x plus y equals 2. So first step, I'm going to add x to both sides. Y equals x plus 2. Again, the coefficient in front of y is just 1, which is fine. We don't need to do anything with that. That's what we actually want. Slope is 1, so rise 1 over 1. Your solution point is going to be where they intersect. So in this case, it'd be 1, 3. Okay, go ahead and try the next one. So I'm going to actually add, don't get thrown off because it's a fraction, just add it to the other side. So you're left with y equals 1/2 x minus 5. Go ahead and graph that. If you're having trouble graphing at this point, definitely you want to talk to me because at this point you guys should be pros at graphing y equals mx plus b. Okay, second equation, y minus 9 equals negative 3x. So my x is already on the other side, which is good. The 9, now I don't want to divide by 9 because it's not attached to the y. Instead, it's being subtracted. So that just means we want to add it to the other side. So y equals negative 3x plus 9. So down 3 over 1. So in this case, your solution point's going to be 4, negative 3. moving on. So last part we're going to do, I know there's another page after this, but we're going to save that page for when I come back. Okay, so these are the last two problems. So again, notice we need to rewrite. I'm going to try and write a little bit smaller. 3x plus 4y equals 12. So subtract 3x. I don't know if you guys can hear my neighbors below me. They are pretty loud. No, they are not in my apartment. That is actually someone who lives below me. They just talk loud. Okay, divide everything by 4. Y equals negative 3 over 4x plus 3. While I'm at it, I'm just going to do my second one before I go ahead and graph. Add 6x to both sides. And again, if you feel like you got this, feel free to fast forward to the end when you see the solution. If you don't have it and I'm going too fast, you have the ability to pause me, which you cannot do in class. So take advantage of it now. Using your calculator, you would simplify 6 divided by negative 8, which would be negative 3/4 x minus 3. Okay, go ahead and graph both of these now. Graphing my red one. My slope is negative 3/4, so go down 3 over to the right 4. Okay, doing my blue one. Again, negative 4, so you can go down 3 to the right 4. Hopefully you guys have realized something already though. Again, if you notice, these are parallel lines. So there is no solution. Okay, again, you could have seen that from the slope. We have the same exact slope. Okay, last one. So my first one is okay to graph. That's nice, right? Giving you guys a break today. This one we have to rearrange. So subtract 2x from both sides. You're left with 3y equals negative 2x plus 12. Divide everything by 3. So y equals negative 2/3 x plus 4. Okay, graphing my red one first, starting up at 4. And then my slope is down 2 to the right 3, right? Negative 2/3. Down 2 to the right 3. Or up 2 to the left 3. Okay, so there's our first line. Now doing our second line in blue. Okay, well they have the same y-intercept. My slope is negative 2/3, so down 2 over 3. Uh-oh, what's happening? They have the same slope, same y-intercept. They're the same exact equation, right? And there's negative 2/3. there's a negative 2/3. Y-intercepts 4, Y-intercepts 4. So these are the same line. Which means they have infinite solutions. So any point that falls on my blue line is going to fall on my red line, which means it's going to satisfy the equation, right? So infinitely many solutions. So just a little quick recap. The idea of this lesson is that whenever a point intersects with another point, or whenever a line intersects with another line, that is a solution. A solution means that if you take this ordered pair here, oh, and I just erased it. There we go. If you take this ordered pair and you substitute it in to this equation, so you would put 2 in for x, 4 in for y, and then you substitute it in for the second equation, you would get true answers, right? So this ordered pair works in both of your equations. All right, so for the rest of the period, there is a worksheet that you will be turning in, and you should be finishing it you should finish it by the end of class. Okay, I will be grading it, so please make sure you do it. I don't mind if you work with one other person, but it's all about graphing. Some of the equations are in y equals mx plus b form. Other equations, though, you're going to have to do some work and manipulate them to get them into y equals mx plus b form. All right, good luck, and we'll pick up with this tomorrow.